the current element and the magnetic field is always perpendicular to the current element. So if this is the line of the current element and the point P where exactly we observe the magnetic field, summing up of all dl terms is nothing but the line element, which is dl. So for all, if you calculate the line element, it completely covers the circumference of the circle. There is a point P away from this line element which is acting perpendicular to this current. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 3 of chapter 4, Moving Charges and Magnetism. So in today's class, let us deal with something more about the Bayot Savage Law, which we had studied in the earlier session. So we have applications of Bayot Savage Law. There is an important derivation which is for 5 marks. Expression for a magnetic field at a point on the axis of circular current carrying loop. So here the diagram to be drawn is, this is a circular loop and it carries a certain current I. We have to give the expression for a magnetic field. That means we have to find what is B or dB. At a point on the axis, so this is the axis, so at certain point they have asked. So consider this point element and this as one element which is having a elemental length dl and a current I is flowing through that axis of a circular loop. This is a circle, this is said to be the center, that is the origin O, and the distance from here to here, that is from the circumference to the center, is given as radius r. Call this line element as AB and this as A dash B dash. So this is an element which carries a current. That means when there is a carrying of current, according to your right hand thumb rule, when there is a force, that is the current which is given in terms of your thumb side is current, then the closed fingers will be magnetic field. Closed finger in the sense it is perpendicular, the thumb is perpendicular to this fingers, 90 degree. So you get to know that as the current is passing in this way, there is a force which is acting over that loop. And that magnetic force is to be calculated at certain distance but at point P. And that distance, call it as distance x from P. The line element to the point P is being attached. So here let me just draw the dotted lines. It is the same as that of the above diagram. So you have another concept. Okay. So the distance from this line element which you are considering to the point P is known as A. Call this also as A. So now according to this triangle, we have hypotenuse square, because this makes a right angle. Hypotenuse square is equal to sum of square of other two sides r and x. So we have A is equal to root of r square plus x square. Consider this as equation 1. Okay. After this, our duty is to consider according to Bayot Savage Law, because this is the application under which we study about the Bayot Savage Law. So here, according to Bayot Savage Law, what is that we are having? We have dB is equal to nu naught by 4 pi I dl sine theta divided by square of the distance between them. Okay, this is the Bayot Savage Law equation what we had studied. Now take the same setup and take the same basic foundation knowledge for us, and let us carry to the next slide. So the diagram is said to be a circular loop, center with radius r, the distance from P to O is said to be x, and the distance from the line element AB is A. So here also we have A. So now, how exactly the magnetic field act? Now we have the current element, and the magnetic field is always perpendicular to the current element. So if this is the line of the current element and the point P where exactly we observe the magnetic field, then magnetic field is supposed to show a 90 degrees to this current element. Similarly, in this case also we have 90 degree, and there is a 2 vertical components and 1 horizontal component. That is nothing but the resolution of this vector as well as this vector. What is resolution? Splitting up. So if suppose this is a vector and this is an axis, x-axis and y-axis, when you just hold a light over here, torch light over here, where does its shadow fall? Over the x-axis. So this is one shadow, and if suppose you hold a torch over here, the shadow falls over the y-axis, that is this part. So resolution means you're splitting one single vector into 2 halves, okay? So this vector as well as this vector, okay? Similar way, it is being split to x-axis and y-axis in this dotted lines. So the horizontal component and vertical components in this case is being associated with one trigonometric functions, that is, along horizontal case it is dB sine alpha. Here also it is dB sine alpha, alpha angle. This also makes alpha. And here we have dB cos alpha, dB cos alpha. Remember, these two are cos alpha. Both are one and the same, but it is acting along opposite direction. Therefore, it cancels each other. So you don't have anything to do with this vertical concepts, but you add this horizontal component because two of the functions are along one single direction. Okay. So now, according to Bayot Savage Law, Bayot Savage Law, what is that you have? dB is equal to mu naught by 4 pi I dl sine theta divided by the distance between them. Distance, as we had calculated earlier, this will be the distance. So we have root of r square plus x square the whole square. So divided by square of the distance between them, we can take it as a square. Now, as I had told you, sine theta, since theta is equal to 90 degree, because I is perpendicular to the magnetic field. Okay, when this is a case, we have sine 90 degree is nothing but 1. So the equation turns out to be dB is equal to mu naught by 4 pi I dl divided by a square. Now, we resolve these two quantities. So now, due to these components, we have dB sine alpha plus dB sine alpha. Together it gives 2 dB sine alpha. Suppose if you have a n number of elements to be calculated, then it will have n number of dB sin alphas, wherein you will just sum it up. So on summation, summing it up in the sense you have total net magnetic field, it is B, is equal to summation of 2 dB sin alpha. 2 dB sin alpha. Then you can just take it as B is equal to summation to what is dB? dB is nu naught by 4 pi I dl divided by A square. And what is sin alpha? So you know that sin theta is opposite by hypotenuse. So opposite is your R, hypotenuse is A. So sin alpha is R by A. Sin alpha is calculated as R by A. So this can be taken as taking common out 2 nu naught 4 pi I R by A cube, summing up of all dl terms. Summing up of all dl terms is nothing but the line element, which is dl. So for all, if you calculate the line element, it completely covers the circumference of the circle. So circumference of the circle can be calculated as 2 pi r divided by twice the circle. So 2, you have pi r. So now you can rewrite this equation as B is equal to nu naught by 4 pi 2 pi I r square divided by A cube. Now we know what is nu naught by 4 pi, that is into 10 to the power of minus 7. 2 pi I is the current, r is the radius of the loop, A is the distance. So what is that distance value we had kept? That is B is equal to nu naught by 4 pi 2 pi I r square divided by A cube can be written as in this form, that is root of r square plus x square the whole 3. Okay. So taking this out, you can even write nu naught by 4 pi 2 pi I r square divided by r square plus x square the whole 3 by 2, because the root is considered as whole to the power of half. Now the conditions or the cases. If suppose this is case 1. If suppose the point is said to be lying at this point itself, so there is no distance, so you can consider x is equal to 0. If you consider your x is equal to 0, then you have B is equal to nu naught by 4 pi 2 pi I divided by, it becomes r cube and r square cancels, remaining is r. This can be the equation when x is equal to 0. Suppose if this one turn is having n number of turns, then you can write this as case 2. When it has n number of turns, then you can write this equation as nu naught, that is B is equal to nu naught by 4 pi 2 pi I n divided by, this is r square divided by r square plus x square the whole 3 by 2. So this is other set of equation. So this concept is very much important for 5 marks and is a short questions. Okay, that is all about your expression for a magnetic field in a current carrying circular loop. Okay, so I hope you understood this concept for today. Now, knowing this concept, let us just catch over Ampere's circuital law. So what is meant by Ampere's circuital law? So Ampere's circuital law is like the line integral dl for a closed curve enclosing certain area is equal to nu naught times the net current through that area. Net current is called as I, then this will be the vector B. Okay, so this is the concept of, that is concept of Ampere Circuital Law, whose definition is very important for 1 mark. So what is this Ampere Circuital Law? The line integral dl, okay, line integral for a closed curve, that is the magnetic field, is equal to nu naught times the net current through the area bounded by that curve. By writing this equation itself, it is easy for you to predict this statement. This is the definition or the statement of Ampere Circuital Law. So here we are studying the applications of this Ampere Circuital Law. We are finding out the magnetic field due to a straight conductor of an infinite length carrying current. So consider a straight conductor of infinite length which is having a current, name it as X and Y. It is dotted, means infinite length. And then there is a point P away from this line element which is acting perpendicular to this current. So it is carrying current I. So here if you draw a circle, the circle is of radius R and the magnetic field is acting parallel to this. It means to say that magnetic field lines is acting tangent to that circle. That is the tangent to that circle, and that is the circle known as Amperean loop. So now, having this concept, it is time for us to get into the Ampere Circuital Law. So according to Ampere Circuital Law, we have these vector quantities is equal to nu naught into I. Take only the left hand side equation. So line integral B dl can be given as B into dl cos theta, which is the magnitude of it. Since it is parallel to the current element, theta can be called as 0 degree, which is said to be cos 0 degree as 1. So the equation becomes line integral B into dl. The magnetic field is taken outside and only we come up with the integral of the line element. Then we have integral of B into dl is equal to B into line integral of dl. That means to say that it is a complete element. So the line element throughout the circle is nothing but 2 pi r. So dl is equal to 2 pi r concept. So what remains is B into 2 pi r. So now this is said to be equation 2 and this is said to be equation 1. Equate B into 2 pi r for left hand side. So we have B into 2 pi r. So on equating, we have B into 2 pi r is equal to nu naught into I. So B is equal to nu naught by 2 pi r into I is the sequence. So now our duty is to get this into the constant, that is nu naught by 4 pi. So nu naught is there, 2 pi has to become 4 pi. So we have to multiply the numerator with 2 and multiply the denominator also by 2. So it becomes B is equal to nu naught divided by 4 pi 2I divided by R. So this is the concept or this is the expression for magnetic field due to a straight conductor which is having an infinite length and it carries a current. So because of this we can say that magnetic field lines always acts tangential to the circular loop or the Amperean loop. Okay. So in today's class we have studied the expression for a loop which carries certain line element and the magnetic field acting due to that line element on certain point, as well as Ampere Circuital Law and its application in case of magnetic field at certain point due to infinite straight current carrying conductor. So that is all for today. Let us all meet in our next session, that is session 4 of the same chapter. Until then, have a good day. Thank you.